Hello everyone, my name is Maciej Szewczyk, and on this channel you will learn how to solder and understand the principles of electronics. Finally, the time has come, one of the best times. Something will start happening after mastering Ohm's law and Kirchhoff's voltage and current laws. You now have all the knowledge needed to work with one of the most common and exciting components in modern electronics, the light-emitting diode. LED. At the very beginning, I want to inform you that this lesson will be divided into 2 episodes. I want everyone to understand all the information and have a good time playing with the acquired knowledge, which is why I decided to take this step. Today we will learn about a new component, the LED, how to connect it and select the resistor to the diode. In the next part we will explore SMD, surface mount components, including soldering techniques and interpreting their marking codes. The lesson will be very interesting, so buckle up and let's go. I remind you that this entire lesson is also available in article form on our website voltnova-labs.com. I encourage everyone to visit because there is a special simulator that will help you understand electronics more easily. Remember that our mission is to teach you electronics and soldering. Let's start with what an LED actually is. You have certainly encountered these components before because practically most of the lighting available on the market today is based on LEDs. You probably know that they light up and they even come in different colors. We will simply use the term LED, light emitting diode. Let's set aside for now how exactly this element works, meaning how light is created inside, as that's rather advanced knowledge. We will focus on how to properly use LEDs in circuits. This is what the symbol looks like, and you can see that it's a component with polarity. Here we introduce a new term, polarity. I haven't used it before because resistors don't have polarity. Whether you solder them in one direction or the other, they will still work properly. An LED is built from 2 electrodes called the cathode and anode. The anode is positive and the cathode is negative. That's why an LED has polarity and you need to connect it properly to the circuit according to its markings. We already know from the first lesson that we analyze current flow from positive to negative. We also know Kirchhoff's first law, so we will handle connecting the diode to the circuit without any problem. And what if we connected such an LED in reverse polarity? Actually, nothing would happen, and this stems from the general properties of diodes. They conduct in one direction but not the other. But that's a topic for a lesson 7 of our complete electronics course when we will discuss rectifier diodes. On the symbol, it's easy to determine where the anode and cathode are located. Remember, the anode is positive and the cathode is negative. From the symbol, you can also easily see that the arrow indicates the direction of current flow. If it's hard for you to remember these names, I have another tip for you. I will tell you one more recognition method. The line in the symbol is nothing other than minus because it looks like a minus sign. In the back for this lesson we have 2 LEDs, one red and one blue. These are the most common LEDs you can get. Let's see what they look like. They have a lens and metal lids. Look at the length of the lids. One is longer and the other is shorter. As you probably guessed, this means that one is the anode and the other is the cathode. The cathode is the shorter leg, and I always remember it this way. The negative side is always missing something. In this case, it's missing a piece of metal. Now let's ask ourselves a question. How do power LEDs? In most cases, they can be powered with a maximum current of 20 milliamperes. Remember that this is the maximum current that should flow through it. Lower values are perfectly acceptable and even recommended. Many people think that the supply voltage for LEDs is the same for each one. This is incorrect because each LED has a different supply voltage and it depends on the color. Now for another new concept in this episode, characteristics. Practically every electronic component in the world has characteristics, and not just one, sometimes dozens. For LEDs, the most fundamental one is the current voltage characteristic. We can read from is what voltage each color needs to start lighting up. When that voltage is reached, the LED starts conducting, meaning it allows current to pass through it. Look at this. I have an LED here connected to a lab power supply set to 0.5 voltage. As you can see, it's not lighting up. And we are somewhere here on the characteristic curve. But if we exceed this threshold voltage, the LED starts to light up and current starts to flow. Let's look at this image. These are the supply voltages for different colors. And as is typical in electronics, we have ranges. For example, for a red LED, it will be from 1.6 volts to 2.2 volts, or for a blue LED, it will be from 2.9 volts to 4 volts. Stop! Let's refresh the information we have learned. An LED is a component that lights up and has electrodes called the anode and cathode. You need to connect it properly to the circuit so that current with a maximum of 20 milliamperes flows through it, and it must be powered with the appropriate voltage according to its light color. Let's check the characteristic again and notice that once the LED reaches its threshold voltage, it's actually controlled by current. More precisely, control means controlling the brightness. So, the higher the current, the brighter it shines. And how can we control current? And what component resists current? Well, you see, you have answering the questions yourself, and that's why we will now learn how to select a resistor for an LED. We can't really just take any random resistor because as electronics enthusiasts, we need to know what's happening in the circuit and what we want to achieve. That's why we need to stay between 1 milliampere and 20 milliamperes, depending on approximately what brightness we want to achieve. The other thing is that the more current flows, the more current will be drawn from our battery. And we don't want to drain it quickly. So we need to find a compromise, right? No, you are curious about what will happen if we exceed the threshold voltage and, for example, power the LED directly. I will gladly show you. How do we select a resistor for an LED? Of course, for this we use nothing other than Ohm's law. Remember that you can always refer back to lesson 1 for help. Look at our circuits now, and as you can see, we don't have the resistor values listed because that's precisely the task for us. In the back for this lesson, we have two each of 10k ohm, 1k ohm and 2k ohms resistors. So we have nothing left to do but grab something to write with and start calculating. For the first circuit, let's calculate for the red LED. We know we have a supply voltage of 9 volts. Let's say the voltage drop across the red LED is 2 volts. Of course, we know this from our characteristic curve or from the table I showed earlier. And we need to select a resistor to limit the current. But what current value is good? Well, we can actually choose it as we want. The important thing is that it's less than 20 milliamperes and greater than 1 milliampere. To make the calculation easy, I will choose that 7 milliamperes will flow in our circuit. The formula for resistance is U divided by I, right? We have the current, we still need the voltage drop across the resistor, and we will find this using Kirchhoff's second law. The voltage drop across the LED is 2 volts. So we know from the previous lesson that this voltage from the battery divides between the components. So the voltage drop across the resistor is VCC minus the LED supply voltage. 9 volts minus 2 volts equals 7 volts. 7 volts divided by 7 milliamperes gives us 1k ohm. We have such a resistor in our package, so we know the value of the first one. Now let's move on to the second one and calculate it in the same way. The only thing we need to change is the voltage drop value for the blue LED, and it's approximately 3 volts to make the calculation easier. Pause the video now and calculate what this resistance will be. I got 857 ohms for 7 milliamperes, but we don't have this resistor value and it won't be a problem if we solder in a 1k ohm resistor instead. The current value will then be approximately 6 milliamperes, so we are still within our chosen range. Now we have nothing left to do but solder and verify our calculations. First, the soldering. And as I mentioned, LEDs have one leg shorter and the other longer. And we also know that the shorter one is the cathode, meaning negative. On our board we have the symbol drawn and it's already clear that there will be negative and here will be positive. Same with the blue LED. And basically that's it when it comes to soldering. I would also like to remind you that we are not soldering the first circuit because that's for the next lesson. It's time for one of the best moments for a beginner electronics enthusiast. Something will happen. There will be light on our boards. No need to talk more. Let's connect the battery and see how it works. Boom! It's shining beautifully. We are not just going to watch it shine. Let's grab the multimeter and take measurements. You must remember that LEDs have ranges, so if the values differ somewhat, there's no need to worry. Let's first check the voltage across the red LED, and it's even close to what we calculated. So if the voltage is similar, the current will be similar too. We have changed the measurement on the multimeter and check the current. And as we expected, the current is also similar. That's a good sign. Here you can also clearly see that current flows through the meter because when we measure, the circuit starts working. Now the voltage across the blue LED. And as you can see, everything we calculate, all this theory is confirmed in practice. So these laws don't lie. And of course, everything I'm telling you is also true. Only the current remains and I think it's a formality, but let's check and here everything matches too. Remember that you have additional resistors 10k ohms and 2k ohms and the entire kit is yours. So grab a pen, calculate what the current will be with one resistor and what it will be with another. Then solder the old resistor, solder in new ones and verify. I will repeat again, the kit is yours and you can use it however you want. So we have learned about a new component, the LED, and how to select a resistor for it. And of course, how to identify where the anode and cathode are. A very interesting episode because finally something happened, something light up. Finally something visible and exciting. The last circuit from this lesson will be in the next episode where we will learn how to solder SMD, surface mount components, and learn how to select a resistor for 3 LEDs that are also in SMD. And we will also learn how to read the codes visible on them. Thank you very much for watching, subscribe and like to stay up to date. Visit the website voltnova-labs.com and check out the complete electronics kit. See you next time. Bye!